without SPSS after last week. So at the end of today, I am once again going to show you our commander, which does everything SPSS can do in a point and clicky kind of way. So keep in mind that almost everything we're doing today, I'm showing you the little things that you would have to write, even write script in SPSS for, right? And in R you can do a lot more. But if you just want to do a t-test and you're like, I mean, seriously, am I going to sit here and go review my notes and like figure it out? Just pull the data into R Commander and run a t-test. Like, it's really not that complicated, you know? So just keep that in mind before everybody starts to freak out. And it's just like, what is happening to my life? But when you want to do more complicated things, you know, then you know how to do them. And part of what we're doing here is sort of setting you up for being able to do all of those things that you can do in M+ and Amos and, you know, Lizrel and all of those other programs you can do in R. But when you get up to that higher level, if you don't understand sort of what's going on here, you'll be totally lost, right? So we're taking it nice and slow. Everything's going to be okay. You have to follow the first rule, which is don't panic. Nobody needs to panic. So, and keep in mind R Commander. So does everybody have their script?
No.
Okay.
I do now.
Okay. And I was telling you all that one of the fun things that Henry and I, who's a Mac user? Where are Mac people? One of the fun things that we figured out is that if you take a folder and drop it onto your R icon, it sets the working directory, opens up your scripts, pulls up your history, and it's just like, oh, here's everything that you just had, which is pretty impressive. You can't do that on Windows. I tried multiple times, and I tried looking up things that would make it do that, and I was trying.
Mac users win.
One for Macintosh. On the other hand, I just loaded Linux onto my computer at home, so I'm pretty much just telling all of them to go away. But just like, it's not open source code, I don't care. So that's good times, and keep that in mind because it makes your life a lot easier and just sort of restores everything without even having to worry about code and whatnot. Especially, and we figured this out through one of those R things where you're struggling with, why can't we set a working directory? What's going on? And then looked it up online, and we were like, wait a minute, and tried it, and it worked. You know, so that's part of being curious and part of going into the program and learning your stuff. So everybody's going to set their working directory, as usual, so we know where we are.
Do you have the script in R already? Having opened it in R?
Yes. So when you open R, you can go to this little folder that says open, and then open your script. Like, navigate to it and open your script. And then it should come up with one side's the console, one side's the script, just like usual.
I downloaded it, but it's not appearing. Here's R right now, right? It's in WordPad.
No, you're
Close
not in
WordPad.
And here's R.
Okay, so then open.
I know I did this.
Open script.
I did. And I went, that's the word.
That's the wrong name.
And then if I open up all my...
Try all files.
Yeah, you probably put it somewhere.
Scroll down.
I mean, it's not saved yet to this thing. That's something.
Oh, you didn't save it?
I saved it as R. No.
That's script.
Save what's in your notepad into that folder.
But I did. I did sometime tell you.
That's...
And I actually, I did this. And I went into R.
Well, I'm going to be that fancy one day.
And then just like this. Okay.
Sure. There it is. All right.
I know.
So we're back on our favorite data set, the Quine data set. And I figured out what A and N means. Because it's from Australia, it's Aboriginal and not Aboriginal. Just so you know. Which we're going to use today. So we're going to load up our data set. Right? That's just read.table. Header equals true, because otherwise it reads your variable names as something else. It thinks it's another line. And then the next question is, can we see a distribution of the age variable? So the age variable, because this is in Australia, they have Form 0, Form 1, Form 2, Form 3. This is like, I was looking it up to try and figure out the system. This is like primary school and then some sort of like middle school time, and I couldn't get a very clear picture on what the ages are here. But this is, they're using this as age. For us, we would probably use grade or something like that, right? So these are the different grades that they're in. And so we have 27 of our people who are in F0, 46 who are in F1, things like that. Right? Now sometimes you don't want this to be a factor. Right now this is a factor. But you might want it to be numeric. I specifically think of some people who use Likert scales as numeric. So if you had something that came into your system as strongly agree, strongly disagree, you know, and you wanted to change it over into something that's numeric so you can treat it as though it's numeric. You can do something, I'm going to create a new object, right? I'm going to call it age 2. And I'm going to say, take the age from data set 1 and designate it numeric. So when I do that, and I see how it looks now, now I have 1s and 2s and 3s, and that seems to be right, right? So I'm going to check it again and say, okay, F0 became 1, it looks like, because it's got the same frequency count. F1 became 2, F2 became 3, so that's how it fed in. So I can sort of double check that. So this is sort of how you guys can check your recodes, because some people were asking about this. I can also do a table where I say, put together age from data set 1, comma, age 2, that's the variable we just created, the numeric one, and show me how they line up. So I know that F0 was designated as 1, F2, you know, just in case you can't really figure that out. And we're going to be working a lot with tables. I want you guys to know how to redesignate things, and I want you to start getting used to being able to pull stuff out. One of the things about R, for people who work with these monster data sets, right, is that this is one object and this is another object, and R doesn't care that they're different objects. I'm saying pull this column, pull that column, put them together, right? So I don't have to combine them into one large data set. I can just pull something from here, here, and here, which works really well if you have these enormous weights, you have these monster data sets. This is one of the reasons why R is one of the things that is being used the most for big data, right? It handles big data very, very well. So, but we say we don't like them being separate, because sometimes what you want to do is then add those down onto one object, right? You just want one data set that has what you need. So if we remember data frames, right, our data set, Quine, is a data frame because it contains numerical and characters or strings or factors or whatever you want to call them. So it's a data frame. So we say make another data set, and we're going to call it data set 2. And we're going to column bind. We're going to bind the columns together. Everything from data set 1 and age 2, our new variable that we just made. Right? Is that clearish? Yes? Okay. So when we do that, and we know it happened because nothing happens, then we ask for data set 2, right? And we can scroll up here. Scrolling. And see that now we have ID, eth, sex, age, learn, days, age 2. Right? And this seems to go along as well. Here's F0. Here's age 2. So this is age, age 2. And it's going side by side as well. So does that make sense? How we sort of did that data manipulation? We're pulling stuff out of different objects, combining them with other objects. And we're going to make them do all sorts of fun things. So one of the things that you guys probably want to be able to do is to see if variables are normal, right? We like knowing if our variables are normal because most of our tests assume that variables are normal. So there's a few different ways that you can do that. There's a Shapiro-Wilks test, which is a function called Shapiro.test. And it's Kolmogorov-Smirnov test, which is KS test. So here I'm saying from data set 2, pull out the variable called age 2. Right? If I tried this on age, it would tell me no, because age is a factor. So I had to have a numeric variable. And then check it against the probability it's normal. So it gives you this incomprehensible warning, but in essence, it gives you this p-value that says this is probably not normal. And if you think about the way that our variable was laid out with the like 27, 40, I mean, there's 4 levels. It's like, this isn't a normal variable, right? This does not fit the normal distribution. So significant p's are bad here. Then the Shapiro-Wilks test does a very, very similar thing. It says this data is not normal. That's what it's telling you here. Because the e to the 10 means, you know, you're bumping out the zeros. Scientific notation. I mean, we know it's not normal. We're just going to use it anyway, which is what half of you guys do. And then, you know, Emily and Noel and I yell at you, but people do this anyway. We're going to use it as though it's normal for the most part. Just for demonstration purposes. Don't do this, it's bad. So, are there questions on what we just did? Making things numeric, adding them back in. Just a univariate test for normality. We're good? Okay. Chi-square is another thing that you guys are going to use fairly frequently. And it's called chi-sq.tst. Is the function, right? So we want it to do something. We want it to do something, and we want it to compare ethnicity by learner. There's apparently like slow, advanced learner in this data set. So when we do that, it gives us back this thing that's like kind of unsatisfying in a lot of ways if you're used to, you know, all this output coming back. But on the other hand, R only gives you what you ask for in a lot of ways. It's not going to do screen after screen after screen of output. I know it's like SAS output sometimes. I'm like, okay, option, I need to turn this off because it's just crazy. So it's just going to give you exactly what it thinks you want, right? So we have Aboriginal or not. We have like normal versus slow learner or something like that. The chi-squared values here. Degrees of freedom is 1. P-value, it's saying this is not significant. But that's not all that you guys want to see, right? So here's where we become good R learners. And it's going to pull up. When you do that, I just asked question mark, chi-square test. I said, what else is there? So when I do that, it gives me all the things that have chi-square.test in it. And it's just this thing, because this is a very specific function. So when I go to that, because part of this is you all learning how to get more information, it says do chi-square.test, you've got an X, you've got a Y, you can do corrections, etc., etc. You can designate your own p-values, you can do all these fun things. But what we care about is what is it saving that we don't know it's saving. So you guys remember when I was talking about lists and I said we're going to be using lists when we get into tests? This is where we're going to start using lists, right? So what it has, if we put this chi-square into an object, we can pull things out of this object. So if we said model 1 and then did the arrow chi-square test, exactly what we just did, then the results are saved in an object, right? So the data's in objects, the results are in objects, like it starts to just keep your brain going. Objects are okay. So it's telling you there's a list, and the list has all of these things in it if you know how to find them. You can pull out the statistics. You can pull out the parameters. You can pull out the p-values. We could run a whole series of these and just stack up all the statistics into one vector, right? And stack up all the p-values into one vector. If we wanted to then like print it out in something pretty and stuff like that. You can ask it for observed and expected counts. You can ask it for the residuals. You can ask it for standardized residuals. It's just not spitting it out on the screen. It's there. Okay, so I'm question mark, but this is what I do all day long in R. Like, okay, what can I find in here? What am I not seeing? I know you have what I want you to have. So how do I get to it? So if I go back here, it saved our chi-square results in a list. So that's what we're going to do. We're going to call it chi-results, right? So now we've just done the same chi-square test we did before, but we've put it into an object that I'm calling chi-results. And then, just like we were doing with the data, just like with other objects, I say I want to pull out something called statistic. And I know it's called statistic because I just saw it on that other screen, right? So when I do that, it says, look, here's the chi-square value. It matches that, right? That already sweetly prints out for you. So does the parameter, degrees of freedom. So does the p-value. We already saw that. The method is what method was I using? Because of course there's always different ways to do things. The data name, if you somehow have forgotten what you were comparing, it comes back and says you were looking at this column and this column. If somehow you managed to forget in the last 2 minutes. There's our observed values. So this is the average learner, slow learner, aboriginal, not aboriginal. That's what we saw. Here's what we expected. Right? And for the most part, when you're a student and you're learning, you learn all about these things. But for people, I mean, I've never actually put observed and expected values in an article like ever in my life. So, you know, this is sort of for us to see like what's off balance, you know, and trying to figure out. But of course, our value is not significant because the observed and expected match very well, and you know that from the residuals as well. Okay? And then they have standardized residuals. So does that make sense that all objects are being treated the same? Even our results are an object. And we're just pulling stuff out of it. Saying, give me this value, give me that value, give me this value. Correlations and covariances are actually very easy. Once again, I do my R Commander plug because they're even easier in R Commander. So do not panic. I am saying here, I want a covariance between, in data set 2, because that's the one that has our age 2 variable, right, that we made into numeric, and the number of days of school that they're missing. So maybe you skip school more when you're older. And then I want that done by a Pearson comparison, because I can designate different methods. And if I wanted to know what methods I could use, I can do question mark. Actually, because it's a function, I can just do question mark cov. and it tells me all the things that I can use. Right? I can use Pearson, Kendall, or Spearman. I can also do, I can tell it whether or not it should remove missing values. I can tell it whether or not it should use everything, which means that it's just filling in. If there's missings, all observations, complete observations, pairwise complete observations, the same thing you guys are used to when you're creating a big matrix of correlation values, right? You can go back in and redesignate that. And you know that it's there because you go and ask that question. What can I do within this function? Or you go the easy way and point and click.
What's the difference between the one question mark versus your question chi-squared test?
The one question mark is sort of like searching keywords. So it'll find you functions or like the exact names of data sets or like the names of packages and stuff like that. The question mark means it's searching all help everywhere. So if I did a search for, let me think of something, like t-test, let's see what happens. So here's all, if I did a search and I put it within the strings and I said search for this phrase, search for the phrase t-test, right? These are all the things that have a t-test in it. So it's like, okay, what do you mean by t-test? But if I did a search for the function that we were using, so if I tried just question mark t-test, it's going to yell at me. It's like, no documentation, what are you trying about? And it says, you could try, like it's really helpful, right? Why don't you try this? Because it doesn't exist. But if I look for question mark t.test, it pulls up t.test. So like it's sort of like searching keywords versus searching everything.
And then the quotation marks you have here but not above, when do you use those quotation marks?
Normally, if you have a space, it doesn't seem to mind the slashes and the dots, but if you have a space or something like that in your search phrase, it can get unhappy. So I normally try it without, and then it yells at me, and I'm like, I'll try it with, and at some point in time, it'll tell me the information that I want. So I'm going to run that again. So this is very similar. This is not a covariance, it's a correlation between age and days. And we look at this and we're like, okay, that's a correlation coefficient. How does this help me? Right? Maybe what we really want is core.test, right? A correlation test. So that's a little bit, you know, it's just straight up giving you this is the covariance, this is correlation. It's not giving you any evaluation for it. So you want core.test to say, is this a significant correlation between these two? And I asked it to do Pearson. So it gives you an estimate, degrees of freedom, a p-value. It gives you a 95% confidence interval. Yeah, this is a T. There's the correlation. So this is Pearson's R. So this is a confidence interval for this, right? If I wanted to have something different here, like let's say I wanted it to be 99%, I can say conf.level equals 0.99, and I believe I do this later on. So I can change my confidence level, if that makes me really happy. And now it's giving me a 99% confidence interval for this same value. Right? Does that make sense? Okay. So, and I would know what the default was, A, because it's printed out as 95% confidence interval, but B, I could also look at the documentation for that. T-test. So you can do a whole bunch of really fun things in R. One of the things that I like about it is that you can do proportion tests as well. and you can do them with summary data and stuff like that. So, I mean, if I knew the mean and standard deviations that I had, I can actually just plug them into a t-test here. You know, I can plug my proportions into a proportion test. This is something that Minitab has that I haven't seen in the other programs. So you can use summary data like a little bit more easily than you would do otherwise. But here we have our raw data. So we want to know days is the number of days you've skipped school. Does that not equal to 0, right? Because that's our default for just a one sample t-test. Is it different from 0? Is mu different from 0, right? So when I do that, it spits me back out. Here's the t-value, here's our degrees of freedom, here's our p-value. It's giving you the 95% confidence interval by default, and here's the mean. So the mean was 16 days missing school. Let's say that, oh, here is where I set a higher confidence level. So now we change the confidence interval again. Confidence interval's a little bit wider. And then we can say, well, what we really want to know is the number of days missed actually greater than 12? And so we can ask that question by going back in our t-test and just saying alternative equals greater, because by default it's a two-sided test, right? So the alternative is we want to know if it's greater, and we're setting our mu at 12. Is that clearish? So I think for most of these things, once you have the code, it all starts to make like a good amount of sense, right? So it's saying, here's my t-value, here are my degrees of freedom, here's my p-value. My confidence interval goes from 14 to infinity, right? Remember our INF means infinity. And the mean, of course, is always staying the same, because that's derived from your sample. So I wanted to show you guys some data manipulation in this provided, or data creation that's provided an opportunity. So let's do a paired t-test. So I wanted to create another variable that I'm just manufacturing called days 2, right? So the number of days you've missed school. So if you had like a before and after kind of thing. So I just said, here's a second variable called days, which is just the variable from dataset 2 called days, plus draw from, and this is where everybody but the most statty of us should shut their ears, draw from a random normal distribution 146 values with a standard deviation of 5 and add it on. So I introduced a little wobble into it. A lot of the power of R also for coders like me comes from the ability to create data really, really fast. So I say just give it a little wobble and make it a new thing, right? So that was my way of making us another variable fairly fast. And then we can paste them side by side. So I just asked it to paste, you can see here. So this was our original days, and it took that number and added a draw from a random normal distribution with a mean of 0, standard deviation of 5, and added it on for me. Which means you do end up with negative days missed as well. But that's an easy way to do some simulations. So, and I also wanted to see you guys that you could just paste stuff side by side if you just want to see it side by side.
The new and the old variable. The new and the old variable.
Mm-hmm. And I could have done this in table too, right? I could have said table this, and it should have printed them side by side for me. One of the things about R is that there are a lot of ways to do stuff in R. Right? So people get confused because they'll see somebody else's code and they'll be like, oh, I don't know that function. But you can go and look it up. So a lot of them function in the same way. and do the same things. A lot of times I'm sitting there saying, why would I want to use this? Why would I put myself through this? So then we're going to create another data set called data set 3. And at that point in time, we're doing the data frame because we're combining data set 2 that we already had, and we're adding a new variable on called days 2. So we're just going to put it all in together. And so now we see like our columns are getting bigger and bigger and bigger, right? Because here's our age 2, now here's our days 2, and they're side by side, and you can see that they're similar. So I want you all to be able to get used to manipulating and pulling out data. Are you guys okay?
I'm being disruptive. I'm sorry.
Emily, do you want to share with the rest of the class? Oh no, you should always celebrate your victories. There you go. There we go.
So, Kat, say that you were trying to, like, say you didn't know pace and you had forgotten table. How would you have called up the help to ask for that? Like, would you have said, question mark, how do I paste stuff to show next to each other? Like, what would your language, like, what would you have written? Like, it's not a Google search, so like, what would I have written to figure that out?
Well, but you can Google search.
Oh, would that be easier?
Do not underestimate the power of Google in terms of how do I do this in R,
Okay.
right?
So would that be a better first step than if I didn't, like, cause like
I mean,
like list output or like I would never thought to put paste output, right? So like, would it be better than if I wanted to do what you just did to go to Google first, or to try it with an R with the question mark? Or?
I normally try some usual suspects of keywords in R. So it'd be like view table, view list,
Okay.
view something,
Okay.
you know, print table,
Okay.
you know, things like that.
All one word? And how can you do it, what you just said?
Like I would try, it's not going to like the spaces, so we're going to do this. And we'll see if it comes up with anything. It's like no results found. I don't even know what you're talking about, right? So then I would just keep trying. And if you know the word table, then that's actually like a better word, because everybody's got a lot to say about tables. So this is going to pull up and you see all these crazy, crazy things and you're like, oh, I don't even know what I want because there's 40 million different packages in R. And I normally scroll down, 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 way far down, far down, far down. Look at all these tables. This is crazy, right? Until you get to things called base, which are normally near the very, very bottom. Because for most of what we're doing, it's not a special package, right? So those up there, they're saying there's a package called X table. And there's something called table within it that is doing table. There's a package called vgam. There's a package called, so that's what the first one is. There's a package called base, and base means the base, R, like what we're using right now. So normally there's something within base that probably isn't, it's not the fancy thing that's going on in deducer, which you probably don't want. It's not the fancy stuff that's going on in X table, which does LaTeX code, which is really cool. But you don't want that, you know, like it's not any, it's going to be something basic. And that's normally toward the very, very bottom is where you can find base, like documentation on base. So that's what I would do. I would also go to the Intro to R help manual that's on R. And you just do like help.start. So. And I would also consider going to the Quick R site that I sent you guys. Right? Because then it's like a page where he sort of explains things really well and step by step. And there's things in there about like how do I view output and stuff like that. So I tried to send you the resources to be mostly self-sustaining and not terribly confused and not sitting there for 2 hours being like, I just wanted to see a table. But I know that Tommy and I were trying to figure out how to output something the other day, right? And so we're like, I'm looking at output. I'm just like, I don't even know how to do this. You know how we do read.table? You can do write.table. And that outputs your data. Yeah, that took a minute, you know, and it's just like very, very frustrating. I mean, I think it's fun, but we eventually figured out read.table, write.table because I had forgotten. You know, I normally don't do that. I just keep all my data in objects. So There are little things like that, I mean, that you start getting used to, and then you get a poster on your wall and you just write down stuff like that. I've been known to do that, just have poster board and just write down code. So, but that's the way I would do it. So for a regular t-test, right, we just said a t-test between, where were we? For one sample, it was just that data. Here we're trying to do a paired one. So we're going to say pull days and days 2 that we just created, paired equals true. Because the default is paired equals false. So we're changing it and saying this is paired. So it's just paired equals true. And then it even tells you when you use paired t-test, just in case you forgot, Kat. Here's the t, degrees of freedom, p-value, confidence interval, the mean of the differences. This is what we expected. So we can do a little comparison between that and what if I do a t-test on subtracting one from the other, just like a change score. I'm going to subtract days from days 2 because that's something we're fairly used to. It's the same thing, right? Exactly what we would expect. So we have 2 sample t-tests. I'm saying give me a t-test, t.test again, of age 2 by ethnicity. So here the order matters, right? Before the order didn't really matter as much. Here the order matters because this is my group. This is my grouping variable. And then here is the thing I want to compare them on. And then there's a little squiggly. You'll see the little squiggly a lot. And we're going to see the squiggly a lot in regression. A lot. Oh. Okay. And I set my alternative, I think this is the default, but I just like to state it to 2-sided, so it's 2-sided. So it's telling you what you're doing. Here's the t-values, here's the degrees of freedom, p-value. Do you notice what it's doing with the degrees of freedom? Do you guys know this word? Do you actually know what SPSS is doing when you say unequal variances? Now, R knows that most of the time your groups don't have equal variances, or that you should at least, before you assume things have equal variances, do a test for equality of variances. But people don't, because they sit there and they point and click and do things that they shouldn't be doing, right? So R stops you and says, I'm going to do this degrees of freedom approximation for the Welch test, and the reason I'm going to do that is because I'm going to naturally assume that you do not have equal variances between groups. So are the aboriginal variance the same as the non-aboriginal variance? It's assuming that it just naturally assumes no. So then it's really, all right, well, how do we test for homogeneity of variance, right? That's really what we want to know. So we're going to do a Levine's or Levine's or it's Levine test for homogeneity of variance. And that's easily found within the CAR package, right? So here I'm going to say, this is me showing you another way of doing things that sometimes works, right? So if you've noticed, we've been writing like data set 2, the little $, then the variable. Data set 2 this, data set 2 this. And that can get really, really exhausting. So I can say with data set 2. So like using the stuff only from data set 2. And this only works if everything's within one object, right? So I'm saying using data set 2, conduct this Levine test for age 2 by ethnicity. I could also have left this off and said dataset 2 $, dataset 2 $, ethnicity. Right? But if you're doing variable after variable after variable, then it's just like exhausting. library is you are going and pulling out a package. You're saying load this package up for me, because we already have installed these. I believe we have installed these. Everyone has installed these? I think this was on my list. Okay.
And you knew to do library car because you looked it up and you knew that that was what you wanted to do for our regression, is that right? Our regression? Like, how did I know to use library? Like, we downloaded library, yeah? But so far we've only downloaded library 4, and how did I know to use library car?
Let's say that you weren't here, you know. But I know that this is a homogeneity of variance test. So I'm going to search for it. And it's telling you that in the car package, you can actually do a test. And that's probably the test that you want. So if you didn't know, you'd be like, oh, somebody's done this. Because somebody's always done this.
Okay. But if I had just run your second line, like the dataset 2, you know, the dataset, that would have pulled up the same result. You're saying this is just like a shorthand library car, or like it's a necessary thing, or it's more of a shortcut, or?
I think mine's already loaded. I mean, you at least have to have it in your system. I think it depends on your operating system. Because this is a function that is within the car package. If it hasn't gone and gotten it off the shelf and put it on your desk, then it doesn't pull up all the functions. So if you think about how many packages I have, which is probably on my home computer 200, right? What you don't want to end up doing is having 200 books open. Because every function, so this is a function, you're telling it to do something to this object, they'll start to overlap each other, if that makes sense. So programmers try not to do that, but sometimes they will. So it's like the function might mean that it's pulling from this package or it's pulling from this package, and your desk is a mess. That's really what it comes down to. So you're going and getting the right book off the shelf and saying, I want the function that's in this book. Open it up. And then there's a chapter in that book called the Levine test. Right? Does that make sense? Okay. So you can have like hundreds and thousands, obviously there's like 3,000 packages, right, on your shelf, but you don't want that in your system all the time. You don't want all of that pulled up in your system all the time. You don't want to slow down your system like that. You don't want to download everything and kill all your memory. That's why one of the first things I wrote to you guys was like, do not download all the packages ever. There's a button that you can do that. It's like, no, just don't. There's 3,000 something. You know, it's just really, really crazy. It'll just drive you nuts.
So what other instances would you need to specify the library? Like we did 4 in at the beginning, we did car for this.
If it's a function that's not in the base package.
Okay.
So anything that's in the base package will just come up. Right, because it's part of the core.
So if I hadn't had library, would have given me an error message then, or if your first line had not been there, library car, would an error message have resulted, or because it
should have, yeah.
The base package, or
it should have. But what I'm saying is, some people's operating systems, and if you're working with an RStudio, sometimes RStudio is nice to you and it'll go get things for you.
Oh, okay.
But it should give you an error, just like I don't even know what you're talking about. Like, what are you trying to do? You have to say, go get that book. Go get it off the shelf and bring it here and open it up.
Can I just put the guys on that? So, what if I don't know what's called Levine's test? But I just typed in homogeneity and it got me to another page of different tests. And like, what I mean is I don't know sometimes I don't know the actual names, but I know, all right, this is what I have to do. So I tried like 4 different variations with the question mark, and the only thing it did was get me to a place that was homogeneity of variances test, but it wasn't the Levine one. Didn't even offer that as a possibility. So then I wouldn't have ended up doing it. See, so.
I mean, I think part of what we're trying to do in these workshops is make sure that you guys have the skills to do the things that you do on a regular basis, or you should be doing, so that you know what you're searching for. I mean, I think part of the beauty of R is we call it opening the black box, right? So you do a lot of things within the programs and you don't know what they're doing. And they're doing a lot of things for you automatically and you don't know what they're doing. And that's a problem. And it's becoming more and more of a problem the more we're dealing with enormous data sets, the more we're dealing with multiple data sets, the more, we have a lot of specialized ways in which we are constructing data, nested data and things like that, and longitudinal and FSHD. I mean, we're the complicated people. We have these huge, complicated studies, and so, I'm trying to give you everything that I think you could possibly need, just in general.
Well, what it's making me see is that it's probably a really good thing to know the actual name of the test, because if you do, you can probably get right to where you need to go.
Right.
Right. Okay.
Right.
That's true.
Right.
With SAS, you didn't really need to go do that.
Yep. So we asked for our test, and it says I have 1 degree of freedom for this grouping variable, this ethnicity variable, which makes sense because we've got Aboriginal and not Aboriginal. And it seems like they have equal variances, which isn't particularly surprising. Okay. So I could also say, I made this note down here because this is sort of, this is one variable that's in a column and I want it grouped by this variable, right? But sometimes you'll have 2 columns of data, 2 different variables. You want to say, are these variances equal? Just in case that's the way your data is set up, I wanted you to have this. So this is a var.test. It's a test of equality of variance between 2 variables. I mean, when I run this, it's the same variable, so remarkably, they have the same variance. So the ratio of our variances is 1 here because it's the same thing. But does that make sense? I guess I should have put in days 2 here. So we expect, even though I introduced it a little wiggle room in days 2, that they're going to have fairly equal variances. It's not really surprising. So we can change the default on our t-test here. So we're seeing the difference between 2 groups on H2 by ethnicity. We're saying the alternative hypothesis is 2-sided. And then we have to change the default. This was all to get to change this default to say variances var.equal, equal variances equals true. Right? And some of you, now that you know that, will go back and just say that as a matter of course, but you should actually test for this. So we always want to be able to see our data, right? Everybody loves pictures. R is good in that it the code will come up with pictures for you. So if I say, this is going to be kind of scary but true, plot data set 3. It took every single variable in data set 3 and compared them and plotted them against each other, right? So this is ID by days 2. And it looks cloudy, which we would expect because there should be no systematic thing about ID, right? It's just an ID number. I mean, it plots everything. So if you have, I have data sets with 10,000 variables, this gets a little hairy pretty fast. But it's also smart in that it will do fun things for you. So I'm going to minimize that. So if I want to plot data set 3 days, which we're treating as though it's numeric, as though it's continuous, by data set 3 days 2, if I run that, and then I don't lose my thing, somewhere in here, here it is. I see it, I see it. If I do that, it says it's 2 numeric variables, I'm treating them as continuous, I'm going to do a scatter plot. You don't have to tell it to do a scatter plot. It's gonna do a scatter plot for you, right? Similarly, Now because I'm not saving these into an object, as I'm running these, they're overriding each other. So I can't go back and get this plot unless I save it into something, right? If I wanted this plot later, I need to save it as something, just so you know. Because it's just going to assume I want to just look at it and then overwrite it. So for something like this, there's actually a cool little thing in the car package. So if you didn't have the library loaded, we'd be loading it again. Called scatterplot. Yes?
With what you just said, so since I've already loaded library car to run the Booleans, do I need to ask for it again?
No.
Okay.
No. You only have to ask for it once within a session. But I didn't want you guys to go and pull this code up later and be like, why can't I use the function scatterplot? And that's because it's within the car package. Because that would make you very frustrated. And you wouldn't remember today. It would be like, it was vague, it was the morning, I don't know, something happened. So, no, once you load it once, I mean, it's not going to blow up your computer or load it again, but once it's pulled it off the shelf once, you don't need to pull it off again. It's there until you close it out. So, the car package has this thing called scatterplot for two variables, for two numeric variables. It does the bar plots along the side and the bar plots along the side, and then it plots, if this was a bivariate normal distribution, what would my confidence interval be? Those are the red lines. And then it's plotting a line down the middle. So it can be something to see if your variables are bivariate normally distributed, right? One of the things we see here is there's not a lot of kids missing school. And this is our made-up data anyway, so we're just making stuff up. But it's a pretty cool diagnostic tool just to be able to see things visually and have it, what would it be like? Does that make sense? Okay. I like it. So I just plotted days by ethnicity, right? This makes very, very little sense when you're looking at it, because this is the Aboriginal people and the non-Aboriginal people. And I'm like, what on earth? This is also explains, if this was up here, a logistic distribution. But if I switch it to where ethnicity comes first and then days, right? Because this is X and this is Y. So here I said plot days on the X, plot eth on the Y, and it said, okay, if that's what you want, this is what I'm going to give you. But if we do it the other way, then it automatically goes through and gives us a box plot. And says, I think that's probably what you want, given what your data is. So it's a really cool way just to look at data really fast and, you know, have it intuit what it is that you probably want to see. I can also do some fancier things, and I just wanted to show you guys a little bit of this. So I can go and plot. This is another way. I'm always showing you, like, this is another way to think about it, but just in case you see it in somebody's code, you're going to find your own way. You're going to find your own way. But here, I can do this, which is the same as this. Plot days by ethnicity. The data is data set 3. So you guys see how I keep saying there's like a bunch of different ways to get to what you want. And this works well if all of your data is in the same object, right? If your data is not all in the same object, you need to do these beforehand. So it depends on what you've put things into, but this can be a shortcut, specifically if you're doing a lot of them. Then I'm saying, give me a title. And I want my title to be box plot of days absent by ethnicity. And I want you to label ethnicity on the x-axis, x label, x lab. And I want you to label days absent. One of the things I love about R is that it produces really pretty plots if you can just mess with them for a minute. So when I do that, It just did what I asked it to, right? But our labels for ethnicity before were A and N. Aboriginal, not Aboriginal. And that doesn't make any sense to me. So if I wanted to produce this for publication rather than for my own, nefarious purposes, I would go back and say the levels of data set 3 for ethnicity, I want you to call them something. Now I know what order I'm putting them in, right? So I'm saying call them Aboriginal and not Aboriginal. If I didn't know what order I was putting them in, I could always just take this levels data set 3 ethnicity and run it, and it's telling me what my levels are, A and N, right? I mean, I sort of knew that from the graph, but it'll tell you them in order and stuff like that. But I know that from the graph. So Aboriginal, not Aboriginal. So that means I'm putting in a column that says Aboriginal and not Aboriginal. So I run that. So I'm saying in the levels of data set ethnicity, this is what you're going to call them. And then I run that. Those next 2 lines, and now it looks pretty. Right? So there are ways to go back and change your data, and I want you guys to know how to do that and be used to changing your data. There are also point and clicky kind of ways in our Commander. We will talk about our Commander because everybody's panicking. Don't panic. So I can also, in our data set, we have this variable called sex, which is currently M and F. So it's like, hey, while we're here, let's call them male and female. And then if I call it up, before it said M and F, and now this is part of going back and forth between plots. No, don't make me lose you. Now it's telling me my levels are female and male. And if I go back and ask it this same question again, what are my levels for ethnicity? Now that I've already redone them, sorry, I'm used to my enormous screens and not this screen. And it's saying, before it said A and N, now it's saying Aboriginal and not Aboriginal. So I just took and recoded my data set, right? Okay.
That's what levels does, it's recoding the data set?
It's just changing the labels. So it's saying what are the levels of a factor. We were using them before to make sure that we didn't have coding errors. So like if you have a bunch of undergrads typing in for some reason, for some horrible reason, you have them typing in strongly disagree, they're going to misspell something somewhere along the way, and there's going to be a strongly disagree. And you'll know because when you run levels, it'll say strongly agree, strongly agree, strongly, like it'll show you what you have in there. And then you can just go back and change that. Does that make sense?
So it's labeling from the smallest value to the largest one?
Oh, it's labeling it in order. So if I had put that column in and said, if I put the column in and just said not Aboriginal, Aboriginal, it doesn't care, trust me. It's like, oh sure, that's what it is. It doesn't have any way except knowing that the order was levels. When we did levels, it was AN. And so when we put in our little vector, we said Aboriginal, not Aboriginal. It does what you tell it to. It's not going to correct you. So, but you can do these horrid things in SPSS as well. If you run a recode into the same variable, and then you manage to hit that button twice, you've just recoded your recode. Right? And if you don't have your original values, you have no idea what just happened. Like it's just all gone. It's in the ether. So I always say recode into different variables, but that's just me. All right. So the other thing that we can do are fun proportion tables. So I'll show you guys what that means. And then we're almost done with tables and plots and stuff, but I wanted to at least show you some. So I'm making a new object and I'm calling it eth-sex, which is a combination of ethnicity and sex. And I want to do a proportion table. And this should have spit out. There we go. Oops. Scroll back over. Let me get my windows. Just tile them. All right, you're gonna have to go. There we go. That's better. All right, we're back to where we can see. So I said, you know, what proportion of falls into each of these? Essentially, I can switch it. Doesn't matter. The really cool thing about doing this is that I can plot this. And of course I just minimized my plot, but it just came back. Here's my little bar plot, right? People like bar plots. It's sort of the way you get bar plots, because a bar plot is a table of proportion. And then I'm adding a legend, which doesn't look pretty because of the way that I have my screen. So I'm just trying to show you guys some options for stuff that you can do, and you can mess with it later too. Right? This is really not pretty, but it can look pretty if you don't mess with it the way that I did.
So what do all those things mean? So it's bar plot and variable, and then beside next to that is T the table?
That's saying don't stack Aboriginal on top of not Aboriginal, put it beside it.
So it's saying where to put the label? Or?
No, it's saying where to put the bars.
Oh, where to put the bars, I see.
So if you think of, I could take these and stack them one on top of the other,
Oh, I see.
and it would get up to 1, right? And then you'd have the code, if I hadn't messed up my legend, then you'd have the code of, you know, Aboriginal, not Aboriginal.
So if you didn't specify, like if you just said bar plot at sex 2, what would have been stacked? Like it's a default then it would have stacked, or you have to specify where to put beside or on top, or?
Let's try it. Stacks it.
Oh, it stacks them, so that's like a default then?
Yeah.
Okay,
And then that looks kind of silly to me.
got it.
And we don't generally look at things like that. Like I generally have side-by-sides when I do graphs and stuff. So, yes. All right. Are you guys feeling like you have enough of a basis? I also have tons of materials on plots. If you get into R and you decide that this is the most amazing thing and you want to be able to plot everything for publication and you want to learn how to get from R to LaTeX code, which is actually pretty cool. Most publications accept LaTeX code for tables. And it makes them look like extraordinarily beautiful, but you know, there's all kinds of fun things you can do, and you can also get lost in it with like, I'm gonna move my legend, you know, 0.2 to the left, and in that same way, I get lost in graphs in SAS a lot, where it's just like, wait, what's going on? I can totally get lost in graphs in R. Okay, let me minimize that, get us back to our tiles. ANOVAs. Are you guys ready? Yay, ANOVAs. So, a few things that you need for ANOVAs. One thing that you should know how to do are power tests, right? So, power.ANOVA.test is a power test for an ANOVA. Much like most power analyses, you need to tell it the number of groups. It's assuming you're going to have a balanced design since you're designing this, right? So this is a priori. The n of your groups. So this isn't an overall. This is saying I have 4 groups. I have 30 people in each group. My between variance is 1, and my within variance is 10, right? I'm making stuff up. These are things you get from previous literature. What is going to be your between and within? because a lot of people are asking when you turn in articles for power analysis. So it's reminding you, here's your groups. You got 30 people in each group. Here's your significance level, which of course you can change, right? It even reminds you n is the number in each group. And then here's your power to detect differences. So if you have reviewers who are asking for power analyses, it's actually relatively simple. There's all sorts of cool, like I've used G-Power before too, which is an online thing that you just, it's like a little applet. So when people ask me to do power analyses, I'm like, do you realize this is not that complicated? So. The next thing is assumptions of ANOVAs, right? So if we have an ANOVA, we assume that they are independent observations. You'll know this from your design. I have no R test to tell you whether or not you have independent observations. So if we're just doing a straight up ANOVA, not repeated measures ANOVA, we are assuming the observations are independent. We also assume that they have normally distributed errors. So this is a lot of complicated syntax just to see, are your errors normally distributed? Because you're talking about within groups, right? So that's where I've had people in my office before who've run into trouble with that, where they're like, okay, I can look at the errors for everything, you know, but I don't know how to do it within gender, within race and ethnicity. So I want to look at, like, what does it look like within race, ethnicity, and gender? So that's essentially what we are doing here. We are telling it, what are the dimensions of my data set? Because if you've forgotten what data set 3 looks like, then you can ask it that. And it says, we've got 8 variables and 146 lines, which for us is 146 people, 8 variables, right? And I'm asking that because then I want to say, give me a little vector, right? Give me a column. Make this column repeat missing, NA is missing, 146 times. So that I have something that matches this, right? So I'm creating an empty space, essentially. I'm saying, giving me an empty space. And you guys will end up just being able to, like, copy and paste this code, right? And just insert variable name here, and it'll be fine. So you need to know how many people you have. And then we're doing a loop. Which is why I'm saying you can just copy and paste this. One thing that's important about loops is they've got these brackets. You need both these brackets to do loops, right? And this one actually has to be on its own line. It's a thing. So I'm saying go over this again and again and again. And when ethnicity matches, when the individuals matches this one, right? So when I'm trying to compare 2 variables with each other, you know, I can use like greater than or equal to, less than or equal to. If I want to say equal, in R, it's actually an equal equal. So where this equal equals that, right? Because a lot of times when they're using equals, otherwise they're talking about assigning objects. So for some packages, some people try to transfer from the assigning objects from this arrow to an equal sign, and sometimes it'll work and sometimes it won't. I use the arrow because it always works, right? But that's what the equal means. It's like, set this object equal to this. So then when they're trying to say, are they really equal? It's like equal equal. It's going through this loop, it's selecting them out, and it's subtracting from each of the days the mean for that group, right? So if I scroll over, I'm saying use this select column, it's subtracting the mean for that group. Trust that this is working. If this is very confusing to you, just trust that it's working. And all of this is to figure out if we have normally distributed errors, which you guys don't even normally look at anyway, but you should. So now, once I got this mean removed thing, I asked for something called, it's not you. I should have put these in reverse, sorry. QQ norm. And then I can ask it for the line. right? So this is like, are my errors normally distributed? It doesn't look horribly happy. There's like a lot of curvilinearity going on here. This is where it should be going. I've seen better. I've definitely seen worse. That's one of those things where I'd be like, I don't know if the errors are normally distributed. But it gives you some idea. And then I can also do a histogram of what it looks like. And that doesn't really look, I mean, it's like normal-ish, but not really normal. So then I call things normal-ish. Sort of normal, maybe normal. If I could transform my errors, like possibly might be normal, but probably not. So that's a way to check one of your assumptions, right? The last thing is that ANOVAs assume that you have homogeneity of variance. And we did this before. So I'm going to say, because I can only do the Levene test between one thing and another, right? One variable and another. But I have multiple groups here, right? I want it within ethnicity and sex. So I've seen you guys, I've seen a lot of people struggle with this in SPSS as well, where it's like, how do I see the variance within the groups? I don't even know, and they're trying to figure it out. So this is the way you do it in R. I'm creating a group, and I'm going to paste these two together and separate them by a space. And this will make more sense once we see it. You go away. You tile. So I am saying paste them next to each other. So now for this person up here, for person number 1, he's now an Aboriginal male, right? And that goes all the way down to person number 32, who's now an Aboriginal female. So it's like you're creating one group. Does that make sense? So now each group is one group. So it's usually what I recommend people do in SPSS as well. SAS handles it a little bit better. But this is what you have to do in SPSS as well. So now I want to know, is there homogeneity of variance for age by groups, which we've made ethnicity and sex, right? So each combination of ethnicity and sex now has its own group. Am I making sense? Okay. I can also look at, oh, I put it down here, the levels of the groups. Oh, it's telling me no. Sorry. Hang on. I remember why I did this. So here, it's yelling at you, and it's saying that it took groups and made it into a factor because it wasn't sure if you wanted it a factor before, right? So we took two words, essentially, and pasted them together. Now, what it does here, it says you've got 3 degrees of freedom, which makes sense because it's taking away 1 degree of freedom. We have 4 different groups: Aboriginal male, Aboriginal female, non-Aboriginal male, non-Aboriginal female. And it's saying the homogeneity of variance is okay. But if you don't like it was coerced to factor, then we can just set groups, this is to show you the converse, as a factor, right? So earlier, we took age and turned it numeric, right? We did as dot numeric. Here, we're changing something that's numeric or something that's a list and saying we want this to be a factor. So I want you guys to have all this that you might need. Not because it's actually going to affect what we're doing right now. So if we run that, and now we ask for the levels of the groups, because it knows that it's factor. When I asked before, it said null, because it didn't know it was a factor. Now, because it knows it's a factor, it's saying these are the different levels that you have. Here's your 4 groups. Just in case you've forgotten, Kat, here's your 4 groups. And if I run the same test that we did before, now that this has been set into factors, right? Because I just recoded into the same thing, something I just told you guys never to do. But I took the same object and said, take groups and make it a factor. So now that it knows that it's a factor, it gives me the same test, the same results, but it doesn't give me that scary warning. That's all. Because it already made it into a factor before. It said, I think you wanted this to be a factor, so I'm just going to act like it's a factor. Is that making sense? Ish? All right.
And then again, if you hadn't done the library car, that would be your line preceding that command, right?
Yes. Yes. Or else it would yell at you and be like, I don't know what this is. What are you trying to pull? It'll say something like, cannot find function. So if it said cannot find function Levine test, then you're like, oh, let me go figure out what package that's in if I don't know. All right. We're going to do this the easy way at the end, but I want you guys to get used to this, especially before we get into regression. So now that we know that we've satisfied or not, we're just going to pretend as though we did our assumptions, right? And I know a lot of you don't check your assumptions. Some of you shall remain nameless. But now you at least know how. And I know that some people have gotten stuff back from reviewers that I've seen before that are like, seriously, these groups are really different, and I don't even know why you're trying to compare them. So we're just going to do a straight up main effects novel, or main effects model, or novel. And we're going to use dataset 3, right? So this is that with thing again. And I keep going back and forth because I want you guys to see multiple things. I could also leave this off and say dataset 3 $days, dataset 3 $f, dataset 3 $sex, right? And that would give me the same result. I'm just telling it different ways. So use dataset 3 and run this, right? And this is our function AOV. And what are we doing? We're predicting days by, there's our little squiggly again, ethnicity plus sex. So this is a main effects model, right? It's just this plus this, one or the other. So I also put it down here to show you that another way you could do it was say AOV days plus sex, and then comma, dataset 3. So you're just telling it, and sometimes you'll have to say data equals dataset 3, depending on the function. But for this works as well. It's the same thing. So let's run it. This is sort of unsatisfying, right? I run this, it spits this back out to me. Because what we're saying to ourselves now are like, okay, well, where are the main effects? It's just giving you the omnibus test, right? Which is sort of very frustrating because it's never really what we want to look at. So this is another one of those things where we have a list of things we can get. So we're going to save this, right? Because before, this just printed out on my screen and it's gone. So we're going to save this as an object. We're going to call it sex and nova. And we're going to say, take these results, take this model, and put it into this object. Because I want to do something with it. I want to see something from it. So when I do that, and I say print, it gives me what I had before. So if I've saved this in an object, I don't have to run it again. So it's just printing out the exact summary. This becomes important. I've run models that take 4 days to converge. Like you want to save it someplace. You don't want to just appear on your screen and then be like, whoops, off in the ether. Like, you need this model. You need your residuals. For the summary, this is what you want. This is probably what you've really been waiting to see, right? Main effect for ethnicity, main effect for sex, residuals. Keep in mind this is type 1 sums of squares. you don't know what that means, ask me later. I'll show you type 2 and 3 in a minute. So is that clearish? Yes.
How else to describe that? But like, it's blinking here. I don't know if it's thinking, but nothing has taken that long, and it's been quite some time since I had like highlighted the little first set and had controlled R, and then nothing happened.
I would say save this and reopen it.
Okay, just the script first.
I mean, you want to save what you've been doing so far, and then I would just close out and reopen it. And I would highlight just everything all the way down and just hit run. You know what I mean? And see what happens. It's all very exciting. Okay.
What was the other one when you said with and then the days at 3? You said that's just one way to word it, and then what was the other code?
So I could say here, data set 3 with a little $, select the column days. Data set 3, select the column Fs. Data set 3, select the column sex. But I mean, when we're getting into like these huge regressions and stuff like that, as long as they're coming from the same object, like don't hurt yourself.
So what's AOV?
Analysis of variance.
Oh, okay.
Because we're doing an analysis of variance.
I was expecting to see the test thing there.
Yeah, like an AOV.test, yep.
Yeah, but you don't.
But they didn't name it that. What they named it was AOV. But our commander does this for you. Don't give me that look. Stop panicking. Kaylee's panicking. Stop panicking.
I'm just like, why can't it be consistent?
Because different people wrote things at different points in time. So a lot of times things that are in packages will have longer names because they were written later. I mean, AOV is part of base. So is core, so is, cove, so is mean, so is SD for standard deviation.
You should use core.test.
If you want the actual test of the correlation coefficient, yeah. So, but I mean, there's sort of like what came first within the programming and stuff like that for who was doing it. And if you can't remember, this is why I'm saying like use R commander. I'm going to come back to it at the end of the class, because you could point and click it and it's going to spit out that script and you're going to be like, AOV? I didn't even know that, but you'll see it. And so you can start getting used to sort of the lower level stuff by just doing pointy clicky things. And it prints out the script, so you can see if I was using script, what would I have done? It's really, really, really helpful for a lot of reasons. And people who are terrified can just ignore the script and just run it, So if we want to do an interaction, I'm using the with data set 3 thing, and now I just changed the eth plus sex to eth times sex. One of the cool things about R, like I was saying, it won't let you do terrible things, is that when you do this, and you run the summary, right? Summary, I'm saying, give me back what I want. It put in the interaction, and it put in all the main effects below it. If I had a 3-way interaction, I could just say eth times sex times learn, right, LRN, and it would do that and all the 2-way interactions below it. Because you have to have the lower order interactions. So it's not going to let you not have them, right? I've had students come in and be like, what is going on? And I'm like, where are your 2-way interactions? They're like, what? I'm like, you have a 3-way interaction. Where's your 2-way interaction? They're like, where? So it doesn't even let you do that. And you don't have to write it all out. There are other programs where you have to write it all out. It knows. It's like everything is there. So I think that's pretty sweet, because there are times when I'm like, did I make sure that I've written all my 2-way? I mean, my brain starts frying. Should we get into these huge, huge models? And then invariably I've typed in something incorrectly, and then I have to go figure out what happened. But it's a pretty sweet thing. So it's telling you for each of these, the only thing that appears to be significant even from before is the main effect of ethnicity for the number of days skipping school. All right. So I don't remember why I was showing you list. Probably because we're going to come back to list later for other things, but print and list are the same for ANOVAs. We want to have an interaction plot, right? Everybody loves to be able to look at pretty pictures. If we had a significant interaction, we want to see what's going on. We want to be able to look at it. So all I'm saying here, let me make this so we can see all of it. And you can just end up copying the second line. I'm telling it to fix different things and put in pretty colors and stuff like that. I'm telling it to do funky stuff. Or you could just run it without this and put the parentheses here and it would work. I'm just putting in colors because I like colors. But interaction.plot. And what do I want? I want this factor, ethnicity. I want this factor of sex. And I want you to plot days. So if I highlight all of this and run it, and then pull back up my plot. This is not a significant interaction, but if it was, I'd make a big deal out of it, right? I'd be like, not Aboriginal males. They're crazy, they're skipping school all over the place. And then the world would go nuts and I'd write a big rant and run an intervention, right? Look at all my stars. Okay. Does that make sense? Mm-hmm. Yes. Yes. Two questions.
Is there,
Go ahead. Go ahead.
I was
Ashley.
just going to say, is there like quick code as far as like changing colors of the lines?
I mean, yes.
I mean, is there, is there like a question mark, like question pretty, or?
There are also like fun graphs that we can do. I mean, if you're just going to do a basic graph, I would do it with an R commander. You know, I mean, if you're going to do something for publication, then like I was saying, I have tons of stuff for plots, like tons. R really likes HTML code, so like if you're into publishing websites and putting stuff up on a website and stuff like that, it'll write HTML code like you would not believe and create all of these relative aspect. I mean, it goes on and on and on, right? And it's really like, I mean, you can tell it, I want you to move this to the left, and then I want you to change this red that's a little bit dashy for me, I want it to be, I mean, you can go on and on and on and on. People get rather extensive on their plots. You know, like if I wanted this to say ethnicity, that's just x.lab, the x label. And I would say x.lab equals, because we did that before. Yeah. So you can go lost. Yes?
So pretending this interaction was significant, is there then a follow-up test you could do to test the simple slopes? Because that's not part of this. This is just whether or not the interaction is significant, right?
Right.
Okay.
So when we get into the two-way ANOVAs, I'm going to show you contrasts and stuff like that. Yay! Actually, speak of the devil, model.tables is the next thing that we're running, right? So this is your tables of means. I mean, you guys see this in other programs all the time, right? So here's Aboriginal mean, not Aboriginal mean, female mean, male mean, Aboriginal female mean, Aboriginal male mean. So you can, it's tables of means. You guys have seen this before. But that's not really the follow-up contrast test. Okay. But we're going to get to that. So, I'm like, there's 2 factors. Let's do this with 3 factors, just so that you guys can be used to it. And then we're going to do an ANCOVA. We're still good on time, so. I made age a factor again. I created a variable called age 3. I could just go back to the regular age, but I want you guys to see going back and forth and back and forth and back and forth. So. And then we're going to say, now I want to do an ANOVA, the AOV, an ANOVA. Which one am I on? I'm on this one, yes. Using, so this is doing it the other way, right? Data set 3, days, data set 3F, data set 3, sex, and then age. I couldn't do this just from one data set because I didn't add age onto data set 3, age 3 onto data set 3. If I'd done that, then I just could have done the comma in data set 3 and gotten rid of all this drama. But on the other hand, I know a lot of people use weights, and a lot of your weights come in different data sets, right? So you have like data of weight. So you can just drop a weight on here. And I think within the AOV function, there's also a thing called weights, right? So there's ways to drop weights into these that can be really, really helpful. And that way you don't have to combine everything into one big data set. I mean, I don't know about you, but like I have data sets that are like, this is, you know, the whole longitudinal data set, and this is just 2 years of the longitudinal data set, and this is, you know, it just goes on and on and on and on. It's just like pull a column and call it a day, you know? So if we run that, you're going to see, just like I promised, all I did was that one line, right? This times this times this times this. And it said, okay, I'm going to give you everything because you should be doing everything, right? So I'm going to give you the 3-way, the 2-way, the 2-way, the 2-way, all the main effects, then the residuals, because that's what you should have. So unless you create these things in other programs, like it doesn't automatically happen. So people don't do them right. So that's kind of pretty sweet. And then we can do print or list, and it's doing the same thing as telling you what are your sums of squares. So I pulled us up another package called gmodels, which wasn't on my list. So I wrote this code in here called install packages gmodels, and then it's pulling up what crayon do you want to install from. It's a very small package, so it only takes like a hot second. I scroll down and say, please do that from somewhere within the United States. This is when I should have asked you guys to install. So it's going to help us do some contrast and stuff like that, which are things that people want from ANOVAs. So you should be able to run this, and it should like just do, it's a very small package, very little. Just helping you with contrast. That's all this person wanted to do. He said, I want to do contrast more easily, so I'm going to create a package to do that. I need it. So once we have gmodels, is there anyone who's having trouble getting it? Did everybody like whippity-doo-dah install that package? You feeling good? You feeling like an R rock star? Okay. Think about the first time you tried to install a package, and right now you're just like, I rule. I'm amazing. We all have to celebrate our little victories. So one of the reasons why I wanted this, right, is I pulled up the levels of age 3, which is our factor, and it's saying I have levels 1, 2, 3, and 4, right? And I really want to know what order they're in, because say this was not 1, 2, 3, 4, this was, you know, white, African American, Latino, Asian American, something like that, right? You have to know what order they're going in, because you want to know what contrast column you want to multiply by. So if I want to compare these two, this should be familiar with contrast coefficients, right? I want a -1 here, a 1 here, 0, 0. So if I wanted this follow-up contrast, then I want I want a matrix that says that. This should be familiar from SAS for most people who've gone through other things. So here I say I want to fit a contrast. What do I want to fit it to? I want to fit it to this model because I saved my model, right? I want to fit it to this model right here, which was our three-way. And I want to fit it to age, right? So I'm telling it specifically, I just want to look at differences between ages from this model. And I want to look at the difference between the next to oldest and the oldest group, because that's the order we were going in. So maybe I think like there's something between like junior and senior high or something like that, if we ever figure out what Form 1 and Form 3 and stuff like that. It's Form 3 and Form 4. So maybe I think that senior high students are really the ones who are skipping more, right? That they're the ones who are making it happen. So I say, is there really a difference between the ages at the end? And is there a significant difference? It's saying probably. Except our overall test wasn't significant, so I don't remember. I've been running it and ignoring the results. I'm trying to, create substantive meaning on the fly. It's obviously those older kids are crazy. Oh, it's actually the younger kids who'd be crazy because the estimate's negative. So the younger kids would be bigger because it's the negative. We're a negative. The other thing that people do a lot with contrast is Tukey's HSD. This is kind of crazy to do it within this because we're treating age as a factor. So this is like, not Aboriginal female in this grade minus not Aboriginal male in this grade. It makes a little bit more sense if we only had two factors, or if you scroll way, way back up. And it's showing you the difference between them. Right, so here it's not Aboriginal female minus Aboriginal female. The difference, a lower estimate, upper estimate, things like that. Does that make sense? Some people are like, I'm going to have to go home and figure out what Tukey HSD is. But it's a way to do follow-up contrasts. I mean, Bonferroni, I don't even know why they offer. All you do is take the number of, follow-up contrasts and divide by 4. It's really, yeah. So, one thing that I wanted to show you, within the car package, let me get to the documentation. So that has a lot of cool stuff that John Fox has done, who's a really, really cool guy. So I'm going into the package and going down to the PDF. Because a lot of times, this is also, I hate not being on my own computers. Or I could not pull up a PDF. There we go. So the car package is companion to applied regression. And a lot of times we have some really cool things that if you go through and think, I want something that can probably do this, it's a pretty good bet that John Fox has probably done it. So there's Box-Cox transformations, there's an ANOVA thing, there's contrast, comparing coefficients. I mean, we could do this all day long, right? Because all an ANOVA is just a certain form of regression. And everything's regression to begin with. So some of these things are data sets, some of them they're basically anything that's held within the car package that's an object or a function is going to have a list here. But a lot of times, I don't know what's up with Foxit, but I know when I pull it up in Adobe and it's got those things on the side, then I can just scroll down the list and be like, there it is. That's the function I was looking for. right? So it could be helpful to look through these PDFs as well, because I bet that somebody's done something that you won't, you know? And you're like, oh, leverage plots, because people like to look at those. You know, how much leverage do people have? It's in there somewhere, specifically for very simple regression and ANOVA stuff. He has a lot on this. Okay.
Kat, can you go through where you pulled up that PDF again? I
Mm-hmm.
know that you did question R, but then from the
So I did question car,
sorry.
and it pulls up, for me it pulled up this site, right? Which is companion to applied regression. And then I went to the URL that's for the package. So the other thing that it's giving you, John Fox also has a lot of stuff up on his site, and there's a book called Companion to Applied Regression, which is one of the 4 books that I listed off as like one of the things that people read. And he's also a contributor to the Forge, which is where it means that CAR is always under constant revision. So if something comes up and you've Googled it to death, you've gone to all the little things that I've asked you to, you've looked on the stuff, you've emailed me and we can't figure it out, we're going to ask John, right? And if it really doesn't exist and we just haven't missed something really, really obvious and stupid, the next time he releases it, he's going to release it with our correction, right? I double dog dare you to do that with SAS. Like, I really, really do. So he will fix it for us.
I clicked on that link, but I still can't figure out where the PDF is. Sorry.
So we went here, and there's a thing called reference manual. Every single package will have a reference manual, and they'll all be in fairly standard format, which is a nice thing when you have a whole bunch of people contributing, that the reference manuals actually look and function the same. So you don't have to guesstimate and start all over. Okay? Okay. So the reason why we're pulling up the CAR package, so if you haven't loaded it, you're going to load it from your library, is that one of the things John Fox did was allowed us to do type 2 and type 3 sums of squares. Which is fairly dependent on the data that you have, right? But it's just doing the same thing, and now this says type 2 tests on it. So he's letting you know. For this type 3 sums of squares, just trust. You don't have to change anything on this line. Right here, trust that you need it, okay? You don't need to change anything on it. Just if you want type 3 sums of squares, run this first, right? You need to change your options, just run it, just trust me. Trust that it's true. It's going to make sure that your degrees of freedom are calculated correctly. It's going to do a correction for that. Right? We okay? Everybody's okay? Yay! So our last thing before we pull up our commander is ANCOVAs, analysis of covariance. Right? So age 2 was numeric, right? So if we're treating it as though it's a continuous variable, we use that term rather loosely when we have 1, 2, 3, 4. But people do this with Likert scales all the time. It drives me a little nuts. But we're going to say we want the 3-way interaction between these things for data set 3. Does that make sense? Okay. So it's still just AOV. And so we print it out. It's giving you what you would expect. What you'll notice between the difference between that and 3, so here's our fourth ANOVA, the ANCOVA, and here's our third ANOVA, which was still an ANOVA because this was a factor, right? And it's the degrees of freedom that are changed, right? Is that all clear to you guys from taking ANOVA classes and why that would be in ANCOVAs? Okay. So one of the things that we can do is just printing out our summary in case you'd ever want it. So we can plot let me close that too. We can just tell it to plot the model. So when we tell it to plot the model, right, because these are our results, we're saying plot this model. So we're not saying plot this variable, we're saying show me the model. You see how this scary blank thing comes up and says click or hit enter for next page. So I'm going to hit enter. It says here's your residuals versus fitted values. Right, these are all diagnostics. Here's your normal QQ plot, which looks remarkably like the one that we created through various and sundry means a long, long time ago in script far, far away. It's saying, it's sort of a spread versus residuals, level versus residuals plot, right? So what you want to make sure is that it's not, you know, it would show heteroscedasticity. More of residuals versus leverage. So you have leverage plots, and those are the plots that it gives you. So when you ask for a plot of a model or results or things like that, it's going to give you something different than when you ask for a plot of, because it's saying what is this? Oh, this is a list. This is a list of results. This is a list of results from this model. This is what they want to see. Does that make sense? Is that clearish? Oh, you're an angry thing. So then I'm showing you plot.design, which is another sort of mostly used for main effects, not so much for other things. But this is a plot of the number of days missed by ethnicity and by gender, and it puts it all in the same pretty thing. It reversed it, I guess, so that, you know, you feel better. No. If I saved it in an object, yes. Because I'm just running it as is. It's like, here's your output, now I'm done. It's like peace out, cat. Right, so I could always say, x equals, you know, plot f(x) ANOVA 4. And I should still be able to call up x. Let me close this out and make sure that's true. And that doesn't like me. One thing you can do, I usually write code for many, many things. And it doesn't like doing it for these follows up, is that you can save as a whole bunch of different kinds of files, and you can copy it to the clipboard and you can put it wherever you want. This will be more useful when we have, you know, box plots and scatter plots and stuff like that. But all of these things can be saved in what format would you like it to be in? You know, or you can copy it to a clipboard and drop it in Word. Does that make sense? Okay. All right. So the other thing, the last and final thing to spare Robert some pain and suffering is don't forget about our commander. So if I load up our commander, I was messing with it earlier a little bit, right? And I pull in data set 1. And I go to File. And then I go to Data. I say Import Data. Import data from a text file. That should be good. Yeah, you're going to overwrite that. Take it from Quine tab, right? This is what we've been doing. And I can say, take my data, go to Statistics. I want a one-way ANOVA. I want a paired t-test. I want an independent samples t-test. I want a one-way ANOVA. My groups are eth, because it's one way, I can only pick one of them. My response variable is days. Sure, I want a pairwise comparison of means. Okay, why don't you do that? Right? And there's stuff that we've been doing. AOV, days predicted by ethnicity. What data? It's just data set because that's how we pulled it in. This is the code that we've just been going over. Right? And then it said, give me a summary of it. I didn't show you num_sum. Give me a summary of it by group. So this is partially an answer to your question. And what statistics do I want to see? I want to see mean and standard deviation. Right? So when you're stuck, this is where to go. And this is where to go when you're beginning too. Right? And when you're stuck, it's definitely where you go back to. Because even if you're like, I'm going to learn this script, and I'm like, yay, learn the script. Here's where you start. He's done it for you. He's printing out for you, yes.
Does our commander run things just in the base package or from any other packages you might have?
When you downloaded our commander, if you didn't have it, remember when I was talking about packages with reverse depends? Our commander reverse depends on a slew of other packages. So when you downloaded it, it downloaded package after package after package after package after package. And when you're running something, it's loading it for you. You don't know that it's doing it unless you're going back and looking at the script windows and stuff like that. But it's already pulling up stuff for you. Right there, if I scroll back up, you see how it loaded library multcomp? You don't even know what library multcomp is, but John Fox knows what library multcomp is. So he went back and pulled it up and pulls it into our commander.
But so let's say I want to be running some multi-level models or SEM or something like that, and I download the appropriate packages for that. Can I use the commander interface?
One would wish. One would wish.
No, that's kind of what I was expecting.
There are other things. This is just the basic R commander as well. There are other things that I will play around with, but there's a time series like plugin for R commander. So when you download, like when you load that time series one, this actually does everything I could ever want it to do for time series analysis, which is pretty impressive. And I love time series. So I can do time series within R commander. SEM is much more complicated. There's several packages, and that's why I sent you guys that list of like, here's things you might want to look at for multi-level models. Here's things you want to look at for SEM. Some of the more advanced things have standalone GUIs, like Amelia is an R package that does, you know, multiple imputation. But it also has, if you don't like R, they created their own little thing where it's like click, 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 click. You know, so that makes people really happy, but on the other hand, you don't have any script that you're able to save and run later. So that can really be kind of frustrating. So it depends. So there are plugins that you can look at, and if you do, let's do this. I did question mark R Commander. Actually, I don't think I want to. I think I want a double question mark because there's lots of plugins. So there are different things it's not automatically downloading, right? So sometimes within the generalized linear model, you can do some mixed modeling and things like that. It's got hierarchical analysis. Some of this stuff is a little bit more buggy. I mean, one thing that's not going to be buggy is like running a t-test. You know, our commander will just like run it like that. But there's certain things that it will do and certain things that it can't do. So, but what's not coming up on here actually is the time series one. So if I go to, and we decided we had to have that little slash there, remember, because otherwise you're going to the freaky people that I don't know. Oh, then Melissa decided it looked pretty. So I'm going to my packages right now. And I'm saying sort by name. And I'm saying go to R. So there's all these, right? That they've been doing. Our commander plugin for this. So he keeps adding in little stuff. So it's not necessarily when you download our commander doing the plugin for business and consumer analytics. But if you're a person who works on this floor, the third floor, this might be exactly what you want. You know, so it's going to have certain functions within that business and customer analytics people would really, really like, right? So these are the things that people have been creating. There's also a survival analysis one for the survival package. So if you use the package survival for survival analysis and you're used to that, or you want to be able to use it in a friendlier way, then you can download that plugin, you know, and that becomes part of our commander. So they're telling you stuff that they have here, which is more than is loaded just naturally in it. Does that make sense? Because they don't want you to download this huge program with stuff that you'll never need.
So I got lost in your answer. Casey asked if R had multi-level modeling language, and then I heard, and then I got lost. So what's the answer to this question?
The answer is not as much as you would want from going back to the regular packages.
Okay. In any of them, not just the R commander, but in regular, like regular R, GUI, R commander, multi-level modeling. This does not.
There are multi-level modeling.
Oh no! There's multi-level modeling like coming out the ears. No. She's talking about can we point and click a multi-level model?
Got it.
Right, and I'm saying.
That's buggy. That's the buggy one.
I'm saying it's not as simple as you would like. But on the other hand, like there are packages that are really, really simple and have really simple code. And I tried to note that in that list for you guys, like this one's really easy, this one's more complicated but can do anything on the planet that you'd ever want it to do. You know, to make sure that you're sort of getting the analysis of it as it's going on, and like this is what I know of. And that doesn't mean there aren't other packages out there. You could come back, if you're a multi-level person, you could come back to me later and be like, Kat, I found the best R package. And I would be like, yes, bring it. You know, we're going to put it over the listserv because that's what we do, right? I'm a person-specific data analysis person. I want time series, I want Markov models, I want data mining algorithms. That's what I want, you know. So those are the things that I know best. That's really what it comes down to. I do multi-level when I have to. I do SEM when I have to. But I do it. But
So
it's not my favorite.
This R Studio then, that's like something that we downloaded too, but like what's that?
RStudio for me, specifically, let me save this. Let me save my script. So when I double click on script, I'm getting out of that. I have it loading up into RStudio, and I really like RStudio because I'm a code writer, and it helps keeps things straight. A lot of the Mac users have these sort of features that are built into their version of R for them. So when you're looking at your code here, you know, it looks pretty, and if I start a parentheses in here, when I'm writing code, like let's say I put a parentheses, it automatically puts an endy one for me. You know, so I can't, you know how you're sitting there and like, okay, I had one here, now I need one, you know, your brain just starts exploding. The other thing that it does, let me run some of this, is it's writing my history. It's showing in my workspace what data I have. So as I kept building more and more and more things, it would show me what data I have. It's got the console over here. When I ran all those plots, so we're just gonna let it think for a minute. It's actually pulling up all the searches and stuff that we were doing within here. When I ran all those plots, it's saving them all in one place for me. Right? So it's a way to keep yourself organized, and for people who like code, it keeps me organized really well.
Thank you.
All right. You guys let me know if you have any questions or there's anything else you need.